In this film, we studied how liquids are pumped. Well, let's talk about another type of pump called an air compressor. We're all familiar with a bicycle pump. This simple method uses a piston in a cylinder. As the piston moves downward in the cylinder, it compresses air into a smaller space, thus raising its pressure. This is called compression. In the broadest sense, air compressors include all devices used for raising the pressure of air. Seldom spoken of as compressors are fans and rotary blowers. They are used mainly for moving air rather than compressing it. In some applications, air may be compressed to several thousand psi. The working pressures used in power plants usually average 100 to 115 pounds per square inch gauge. Generally, there are three types of air compressors used in a power plant. They are the rotary, centrifugal, and the reciprocating type. A rotary air compressor is one having a vane rotor mounted eccentrically in a stationary casing. It is only occasionally used in power plants and will not be discussed in this film. A centrifugal pump is one designed to deliver large quantities of air at low pressure, moved by centrifugal force generated by a rapidly revolving rotor. This type of compressor is being used more and more in power plants and will be discussed briefly. The greatest proportion of compressors used in power plants today are of the reciprocating type. This type will be discussed in greater detail. First, let's look at centrifugal compressors. They are similar in design to the centrifugal pump discussed in a prior film. The principal parts are the impeller and the casing. Air enters near the shaft of the impeller and is thrown to the rim. Centrifugal air compressors range from single to 5-stage and can deliver from 20 to 450 psig. In a multi-stage centrifugal compressor, the outlet from the first impeller is connected to the inlet of the second stage impeller through an intercooler. The function of the intercooler is to extract heat from the compressed air. There are many advantages in using a centrifugal compressor. Here are but 4. For a specific output rating, they are more compact and efficient. Centrifugals deliver a smooth flow of air to the air receiver. On the other hand, reciprocating compressors are characterized by pulsations. A safety feature of centrifugal compressors is that no oil enters the airstream, since they do not need cylinder lubrication. Centrifugal compressors are the type in greatest use in power plants today. A reciprocating compressor utilizes the same pumping principle as the bicycle pump, where a piston operates within a tube or cylinder. In a compressor, the piston will have seals or rings to hold the air during compression strokes, and a heavy connecting rod to move the piston. As the piston is moved to the right, air will enter the cylinder through the inlet valve until the piston reaches the end of its stroke. When the cylinder has been filled with air, the piston moves back to the left. The inlet valve will close and the air trapped in the cylinder will then be compressed. The outlet valve. This completes our cycle of the compressor. A mechanical device called a crosshead is frequently used to convert the rotating energy of a motor to linear or reciprocating motion. The crosshead compressor is quite common in power plants. Usually the unit is designed with pairs of air cylinders so that one discharges its pressurized air, the other is drawing in air. This is called a double-acting cylinder. As the piston travel reverses, the newly filled chamber becomes compressed and its air discharges into the system. To carry away the heat of compression, cooling water will usually be piped through the jackets of these rugged workhorse compressors, and should the cooling water fail, internal heat may cause damage to the unit. Now, whether the compressor is single-acting like our bicycle pump or double-acting like this cylinder, which uses both sides of the piston, the air itself passes through only one compression stage. We call this a single-stage compressor. Most power plants use more than one compression stage. A multi-stage compressor consists of 2 or more cylinders in series. Compression begins in one cylinder and is completed in a second cylinder. The first stage or low-pressure cylinder is larger than the second stage, and air is compressed to some pressure in the low-pressure cylinder, then discharged into an intercooler which removes some of the compression heat from the pressurized air. The air is then admitted to the second stage, smaller, high-pressure cylinders, compressed, and then discharged at high pressure into a storage tank, called a receiver. For pressures above 80 pounds per square inch, multi-stage compressors are generally more efficient and economical. there are multi-stage compressors in operation, which utilize as many as 7 stages, single-stage compressors. Another advantage is that multi-stage compressors require less maintenance because lower temperatures permit better lubrication and, of course, reduce deposits on valves. Valves are perhaps the most vital part of any compressor, and they must be both efficient, that is, they must function correctly and easily, and they must be rugged and long-lasting. Compressor valves are devices placed in the cylinder to permit one-way flow of air, either into or out of the cylinder. Valves were formerly mechanically and positively operated. Modern compressors all use some type of automatic or self-operating valve. These are opened solely by the difference in pressure across the valve. Springs are used to assist in the closing. As an example, we'll take a close look at the operation of a heavy-duty channel valve used on large modern compressors. The main parts are a channel, into which a flat curved spring fits. All of this fits into a slot in the seat valve. A stop plate tightly holds the spring in the channel. Now, as air pressure increases, it pushes up against the spring, which is, in turn, pressed against the stop plate. The pressure of the air pushing against the spring causes the valve to open until the spring can again close the valve. This air, under pressure, may pass through another cooling section, or aftercooler, and is then fed into a storage tank called a receiver. The receiver acts much like a water tower. Here, a large quantity of water is instantly available as needed. With such a reserve storage system, the size of the required pump can usually be a great deal smaller than would be necessary if the pump had the same. Now, just as the water pump cycles on and off to maintain the level in the tank, the compressor controls operate to maintain the air pressure in the receiver within preset limits. This regulation or control can be accomplished in 4 ways: manually, automatic start and stop, constant running control, and dual control, which is a combination of the second and third methods. Manual control is rarely used, as someone must be on duty with the pressure switch. The power is cut off when the receiver has reached the desired storage pressure. As pressure drops, and at a predetermined level, the switch cuts in, and the compressor starts up. This type of control is used when the demand for air is infrequent, and the compressor operates less than 50% of the time. With a constant running control, the compressor keeps running, and the air pressure in the receiver is controlled by a pilot-type unloader, which opens or closes the inlet valves. For example, when the air in the receiver is at the desired pressure, the inlet valves are held closed, which does not allow any air to be compressed, allowing the air to be compressed again. Now, this type of control is used when the demand for air is relatively steady. Dual control is a combination of the automatic start and constant speed control methods. Now, depending on the particular demand at the time, a selector switch is turned to the method of control, which is most economical. If a continuous supply of air is needed, the selector switch is set for constant speed. If, on the other hand, the demand is less than 50%, the selector switch is turned to automatic start. Before we continue, let's discuss briefly how manufacturers rate reciprocating compressors. Ratings are in terms of piston displacement. This is the amount of air which would be delivered by the first stage piston if it were 100% efficient. The quantity of air is expressed in cubic feet per minute. Every air compressor should have an intake filter. There's a great deal of dirt in even the cleanest atmospheric air, which will cause unnecessary wear. Most filters are a combination of filter and muffler, which cleans the air and silences the noise. Now let's turn our attention to cooling the air compressors used in the power plant. When air is compressed, as in a compressor, heat is generated. For example, the bicycle pump becomes warm when pumping a tire. Now, this heat of compression must be absorbed in some way because it wastes power. Small compressors are air-cooled. It's the larger compressors with which we're concerned, and we'll discuss 3 water-cooled methods of absorbing the heat. The methods are water-cooled jackets, water-cooled intercoolers, and water-cooled aftercoolers. The water jacket carries off some heat of compression. Multi-stage compressors are an operation which utilize as many as 7 stages, with intercoolers between each stage. The intercooler is an efficient heat exchanger in which cold water passes through a large number of tubes around which the air is flowing. Air leaves the intercooler, goes to the second stage of the compressor, where it's compressed to final design pressure. The compressed air now passes through a water-cooled aftercooler, where heat is extracted, precisely the same way as in the intercooler. From the aftercooler, air passes through a moisture and oil separator. The air makes several sharp reversals of flow so that condensed water vapor will fall to the bottom of the separator and be drained off. After air leaves the water and oil separator, it enters the receiver. Every compressor must have an air receiver. This is a tank into which the compressed air is discharged from the compressor. They act as storage capacity during intervals when demand exceeds the capacity of the compressor, and fittings should include a pressure gauge and a safety valve. Our final topic for study of air compressors is lubrication. Lubrication of a compressor is the most important part in its care and operation. Lack of proper lubrication will damage many parts. Reciprocating compressors have 2 separate lubrication systems. One supplies oil for the cylinder, the other for the bearings and crankcase. 2 very important points to remember in cylinder lubrication are, first, use only a high-grade oil. Low-grade oils result in lower efficiency. And second, it is desirable to use the oil very sparingly. Over-lubrication may result in excessive carbonization of the discharge valves and increased discharge temperatures.
At this time, stop the player and take the quiz in your power plant mechanical systems workbook for air compressors. When you have completed the quiz, restart the player and we will review the answers together.
To 100 today, average 100. Pressure number 1, the answer is B. Pressures used in power plants today average 100 to 115 psig. A multi-stage compressor consists of 2 or more. Stage compressor is one in which the compression cycle takes place in a single cylinder. For question number 3, the 4 methods are air-cooled. This is the method used with small compressors. Water jacket. This method circulates water around the cylinder to absorb some of the heat of compression. The intercooler removes heat from the air between stages. And finally, the aftercooler, where heat is removed again precisely the same way as in an intercooler. Okay, this is the correct labeling of your diagram. Well, this completes the film on compressors, and as always, you may repeat it if you like, or remove it and replace it with your next lesson.